In this video, we're going to go over the Math 1 EOC Inactive questions numbers 6 through 10. For the first question, it says, two boys, Sean and Curtis, went for a walk. Sean began walking 20 seconds earlier than Curtis. Sean walked at a speed of 5 feet per second, and Curtis walked at a speed of 6 feet per second. For how many seconds had Sean been walking at the moment when the two boys had walked exactly the same distance? Okay, so I'm going to go ahead and go to my next slide to help me out with this. This is going to be your equation for Sean, and let me explain why. X represents the number of seconds, and Y represents my total distance. Why? Because it said that he's going 5 feet per second. Okay, so 5 feet per second, 6 feet per second. That means, the other thing that's really important is what? They said that Sean began walking 20 seconds earlier. Okay, so with that being said, that means 20 seconds earlier, well, 20 seconds at 5 feet per second is what? 100. Okay, that's where 100 comes from. Okay, so before Curtis even starts walking, Sean is already 100 feet ahead of him. I'm just going to put feet here to kind of help you keep straight. This tells me my total feet. X represents seconds. Okay, so that's the equation for Sean. Now Curtis, he starts at 0 because he doesn't have it, he's just going. And every time he walks, he covers 6 feet. Okay, so again, Y represents total distance in feet. Now I need to set them equal because I want to know when are their distance the same? When did they walk the same amount? So to solve for X, I get my X's on the same side. That gives me X. Well, remember, X represents what? Number of seconds. So X is how much Sean had walked when, Curtis walks 100 seconds, and Sean walks how many? 100 plus, what was his head start? 20. Okay, so when the question says, how many seconds had Sean been walking at the moment when the two boys had walked the same distance, that was after 100 seconds. So Curtis had been walking 100 seconds, Sean had been walking 100 seconds, plus the 20 head start. So how long had Sean total been walking when they got the same amount of feet? 120 seconds. Okay, question 7 says the math club sells candy bars and drinks during a football game. 60 candy bars and 110 drinks, 120 candy bars and 90 drinks. How much does each candy bar sell for? Hopefully you're recognizing that this is a system of equations and it is set up for you to use the elimination method, okay, which I've done right here. Here are your two equations. I chose to multiply the top. Okay, so I multiply the top by -2. When I do that, I have to multiply it to everybody. Okay? And that's where you see these numbers right here. Now, I'm going to add the two equations together. And that's when you see this cancels. This leaves me with -130. And over here, -260. Well, then, I'll put an arrow in here. If I divide both sides by -130, I get D equals 2. So that's how much drinks cost. So what the question asks, how much does a candy bar sell for? So I have to plug this back in to find the candy. You can plug it into the first equation or the second equation. I'm going to plug it into the first, but if you chose a different one, you should still get the same answer. Okay, so if I say 60 candy bars plus 110 drinks at $2 each equals 265. Well, that's 60C plus 220 equals 265. Then when I subtract 220 from both sides, I'm going to get 60C is equal to 45. Okay? Now I need to divide by 60. They're not making this problem easy. I need to simplify 45 over 60. You could do it a different way, but for me, I realized they were both divisible by 5. So I was like, okay, divide by 5, that's 9 over 12, but that's still not the right thing, so I need to reduce it again. They're both divisible by 3, That gives me 3/4, and I know as a decimal that is 75 cents. Because it said to, how did it say to leave your answer? Dollars, dot, cents. Okay, so if you've rated 3/4, they're not going to give you credit, even though it's equivalent. Okay, you have to do it this way. Okay, number 8. What is the smallest of 3 consecutive positive integers if the product, or this product means multiply, okay, of the smaller 2 integers are positive and negative whole numbers, is 5 less than 5 times the larger. So the key to getting this question right is writing the equation correctly. You have 3 consecutive. Consecutive means back to back. So let's just pretend that this is 1, 2, and 3. If x is 1, how far away is 1 from 2? Plus 1. How far away is 1 from 3? Plus 2. Right? So consecutive means back to back. Then I have my equation. Okay? So this product of the smaller 2 is going to be equal to 5 times the largest minus take away 5. And then from here, I just start solving. Okay, so I distribute, that's x squared plus x equals 5x plus 10 minus 5. I'm going to combine like terms. So 5x plus 5. I'm going to subtract 5x from both sides. So x squared minus 4x equals 5. I'm going to subtract 5 from both sides. X squared minus 4x minus 5 equals 0. From here, I have a quadratic, and I need to factor it. So I know that it's going to be 5 and 1, because that's the only numbers that give you negative 5. And I know that I need to have 4 left over, and that needs to be negative. So this number needs to be negative, and this number needs to be positive. When I set them both equal to 0, I have x plus 1 equals 0, and x minus 5 equals 0, minus 1 plus 5 plus 5. That means that x is equal to negative 1, and x is equal to 5. Well, the question said what? What is the smallest consecutive positive integer? The smallest one that's positive is 5, which means this will be 5, 6, and 7. So the correct answer is 5. Okay. 2 left. Number 9. Models the approximate height of an object t seconds after its launch. How many seconds does it take the object to hit the ground? So you need to remember what that means. What are you looking for? Waiting for an object to hit the ground. Just as a quick reminder, this is a quadratic, and you can see that it's starting at what? 60. It's going down because it's what? Negative. You want to know when is it going to hit the ground. Okay? That means you're looking for your what? Zeros. Okay? So with that being said, I need to factor it. To do that, because I don't have a calculator, I have to factor. To factor, I need to pull out the GCF, especially because I definitely don't like this negative up at the front. They all have what? 5. So negative 5, that's going to give me x squared minus 4x minus 12 equals 0. Negative times a positive makes it negative. Negative times a negative makes it positive. Negative times a negative makes it positive. Good. I factored it correctly. Now, I need to factor out. Okay? So what are the factors of 12 that are going to add up to negative 4? And hopefully you are saying 6 and 2. Okay? I need this to be negative. I need this to be positive for it to make a negative 4. Now I set it equal. This doesn't have a variable on the outside, so I can just leave that. X plus 2 equals 0. X minus 6 equals 0. Minus 2. X equals negative 2. Plus 6. X equals positive 6. Okay? And the question said how many what? Seconds. Can we do with negative seconds? No. So my answer is 6 seconds. Last one. 2 times Antonia's age plus 3 times Sarah's age equals 34. Sarah's age is also 5 times Antonio's age. So when you write these equations, 2 times Antonio's age plus 3 times Sarah's age is 34. Sarah's age is equal to what? 5 times Antonio's age. This is a systems of equations. And hopefully you're realizing it's set up for substitution. I need to plug all of this in for S. I have 2a plus 3 times 5a equals 34. 2a plus 15a equals 34. 2a plus 15 is what? 17a equals 34. Divide by 17, a equals 2. But that's not what the question asked. It said what? How old is Sarah, not Antonia? So I need to plug that back in. So if Sarah is equal to 5 times Antonio, Sarah is equal to 5 times 2, so Sarah is equal to 10. That is the correct answer. That's the last one for this.